Howdy parents. Okay, we've done expanded addition before and expanded subtraction, but we've done it with 2 digits. This time we're going to do it with 3 because we're getting those bigger numbers and we need to understand how this actually works. So when we do stuff in expanded form, it's oftentimes just a reflection of how we as adults think about numbers. The difference is we kind of had to learn that strategy on our own. We're teaching the kids today how to do that stuff pretty early on so they understand how numbers go together and how they're taken apart. So what I've told the kids is, this is your computer, this is your printer. And in order for us to figure out what's going on inside your computer, you have to put it out with your printer so we can read it. So even though a lot of the kids are starting to figure this out and can do some of this stuff in their brain, we need to see it on paper. And it's kind of a good way for them to understand that whole process too, so they really get a good understanding of how those numbers do work. So the first thing we're going to do is our expanded addition. We're going to take those numbers from horizontal to vertical. I'll tell the kids oftentimes we stack them. And we're going to take the numbers and lay them out on their side in their simplest forms. I'm going to break them out into their hundreds, tens, and ones. So it's 126 would be 120 and 6. 139, 130, and 9 more. Now I just get the joy of adding them up like they are. 6 and 9, 15. 20 and 30, 50, and 200. Now being a super smart second grader, I know I can practically read this thing. 250 and 15 more, well I know that 15 makes 10 and 5, so I'm going to take that 10, stack it over here, and now I'm at 260 and 5. Huh, how easy is that? Wow, let's go try it again on subtraction. So again, I'm going to take those numbers from horizontal to vertical to stack, and then lay them back out in their simple form. We do it a little differently though when we lay them out here, because we don't put this and here, this plus symbol. We actually use a dot, because although we're super smart second graders, sometimes we can get confused. It's pretty easy. So if I'm doing subtraction, I know I'm going to put the big fat dot for my and sign. So there's my 200 and 90 and 3. 100 and 60 and 8. Okay, so I'm going to do this. Take a look at it, go, 3 minus 8. Ooh, can't do it. So guess what? I get to actually watch myself go next door, take a whole 10 out, and add that 10 to my 3 to make 13. Now, the kids do this notation sometimes to remind themselves what they're doing. Eventually, that'll just go away, and they'll know it's just 13 minus 8. 5. 80 minus 60, 20. Again with the and symbol. 200 minus 100, 100. So again, I can practically read this in my sleep. 120 and 5. Gee, that sounds an awful lot like 125. See, this is really easy, especially when they're first learning how to do this regrouping and carrying and borrowing thing that we used to do. They actually get to see the process, and eventually this is going to help them learn that algorithm that we all know and love and really want our kids to do badly. No, we want them to do it very well. We badly want them to do that. How's that? Here we go. So we want to see them turn this into that algorithm, but this helps them understand why and how that algorithm works. Then when they get into more advanced maths, guess what? You don't have to teach your kid algebra all over again.